One of the things that happens when you have charges is you have something called field lines. They're drawings of these difficult to understand ideas of how forces can be exerted on other things. So if we have a positive charge, the field lines go out in these directions, right? So we have these going out here. Well, if I have a negative charge, they're going to go in to this charge. And so the positives go out, the negatives go in. And so if I bring these close to each other, we end up with these things beginning to look like this, and we end up with a field of these force lines as we go through. So we have this electric field and we have these force lines. Now, the more lines you have, the greater the force. So if I were to draw some more of these lines in, these two had much higher charge than the previous ones. Does that make sense? The more lines you have, the greater the force. Now, so electric fields are associated with force. So electric fields, we use a capital letter E for electric field, and they're associated with force. And so the force that we have here, as force goes up, electric field goes up. As electric field goes up, force goes up. But it's also inversely proportional to the size of the charge that we're going to move along these lines. So if we're going to move with this, and we're going to move against this, the size of the charge matters. So a bigger charge requires a bigger force in the same magnetic field. Let me say that again. A bigger charge needs a bigger force to have the same magnetic field as a small charge with a small force has with this electric field. So this formula right here deals with forces, charges, and electric fields. Now let's take a look at the units. The units are really straightforward. Newtons are force, charge is coulombs. So the electric field has a unit of newtons per coulomb. Now this becomes very interesting if we take into account Coulomb's law. We have F equals K Q1 Q2 over R squared as force. I could rearrange this to force equals EQ. Now what would happen if I put them together? Put these two things together, because if force is electric field times charge and force is K times two charges divided by R squared, I could put them together and I end up with something that looks like this. K Q1 Q2 over R squared is equal to E times Q. Now the interesting thing about this is one of those Q's, one of these is this one, because you have two charges. So one of them is there. So what we do is we take one of the Q's out, doesn't matter which one, and now you have an aspect that the electric field is K times the Q, the charge that you have, divided by R squared. How far you are away from that charge will tell you what the electric field is at that point. So some pretty creative things taking place here. Electric field is force divided by charge. Coulomb's law is here. If we set them equal, we now have a different equation for an electric field. I hope you find that helpful.